Hi all, today we'll be talking about a Leetcode problem, vertical order traversal of a binary tree. Let us go through the problem statement first. Given the root of a binary tree, calculate the vertical order traversal of the binary tree. For each node at position row column, its left and right children will be at positions row plus 1 and column minus 1 and row plus 1 and column plus 1 respectively. The root of the tree is at 0, 0. The vertical order traversal of a binary tree is a list of top to bottom orderings of each column index, starting from the leftmost column and ending on the rightmost column. There may be multiple nodes in the same row and same column. In such a case, sort these nodes by their values. Return the vertical order traversal of the binary tree. So what does this mean? Let's just try to see that in the given sample examples. So the first thing it says that for any given node, which is at row comma column, that is here 0, 0, its left child will be at row plus 1 and column minus 1, that is row plus 1, 0 plus 1, 1 and 0 minus 1, which is minus 1. And its right child will be at row plus 1 and column plus 1. So basically, this property is followed throughout the tree, and we need to find the vertical order traversal of such a tree. That means that we need to print the nodes falling in the same column number together. That is here the column number the column number is minus 1 here, and there is only one node in this vertical line, so we'll print that. And then in column number 0, there are two nodes falling on this vertical line, that is 3 and 15. We'll print it sorted row wise, like first the node at row number 0 will come, and then the nodes at row number 1 will come. 1 or 2 or similarly. It will be in increasing order of the row number. Then at column number 1, we have one node with value 20, and at column number 2, we have one node with value 7. Now let's go through this tree. For the column number minus 2, we have one node with value 4. For the column number minus 1, we have one node with value 2. For column number 0, we have three nodes. So it will be first sorted on the basis of row number. So first the node at row 0 will come, and then the nodes at row 2 will come, which will be sorted on the basis of their values. So 5 will come first, and then 6 will come. And then we'll go to the next column number, that is 1, and there is one node in it, so we'll print 3, and then there is column number 2 with value of 7. So I think we have understood the problem till now. We basically need to keep track of two things here. We first need a mapping column number wise, like we need to find the nodes which are falling in the same column number first, and then among the nodes falling in the same column number, we first need it sorted by the row number, and secondly, if the row number is same, we need it sorted by the values. Like here, if the value here was 20 or 20 and this was 6, then 6 would come first and then 20 would come. So that's what that means. So let us jump into code. So we'll keep a vector of vector, which will be our answer, and we'll simply return this answer after we have done all the other computations. Apart from that, we need a map for storing our intermediate results. So this map will have the key, which will be the column number, so int, and its value will be a vector of pair of int and int. So what does this vector of pair and int will store? This pair int will store the row number and the value of the node. The row number of the node and the value of the node, because as we discussed, we need the node sorted first by row, and then we need it sorted by the value of the nodes. So that's why it is a pair of intent, and in a given column we can have multiple such nodes, so it will be a vector of such nodes. So we'll first do the basic check. If root is equal to null, we'll return answer, which will be empty initially. Otherwise, we'll do a BFS over this tree. This BFS will contain the tree node. Apart from that, it will contain the row and column number for the given node. Pair, and then the second bracket pair, and then the queue. We'll try to push the root node so that we can start the BFS. So we'll push the root node here, q.push, make pair of root, and then make pair of the row and column number, which is 00 initially, and we'll store this information in map. So in the map at column number 0, we have inserted a node with row 0 and value equals to root's value. Now we'll do BFS over this. So while not q.empty, we'll keep popping the nodes. So tree node star n variable will be q.front dot first, which is the node. We'll store the row information for it in q.front dot second dot first, and the column information for it in variable call q.front dot second. Now we'll pop this node since we've processed it. So if its left child is not null, then we need to push the left child into our queue so that we can process it later. So we'll push q into the queue, the left child of the node, q.push temp.left, and we'll push its row and column number. And as given in the problem statement, for the left child, the row number will be row plus 1 and column minus 1. And we'll update this information in our map that we have inserted a node with at column minus 1 with these values, the row number and the value of the left child. We'll do a similar processing for the temp variables right child. So if temp's right is not equals to null, we'll push it into the queue for processing, and its column number will be column plus 1, row number will remain row plus 1, and we'll update in the map at column plus 1 the row number of the temp's right child, which is row plus 1, and the value of the node itself, because in the answer we need to return the value of the nodes. Now whatever we needed to do in BFS, we have done it, and all the information that we needed is captured in this map. And basically we need to return the answer in the form of vector of vectors. So we'll try to form that vector. So we'll traverse over this map. Auto ID equals to mp.begin. Since the map is always sorted by the keys, so the column number with least value, that is the leftmost column, will come first, and the rightmost column will come at the last. Now we need to sort this map. As we talked, we need to sort this vector, the values in the same column first by the row. That is, the value coming at row 0 will come first, and then the value coming at row 2, row 4, and so on. And then in the same row, like here in the row number 2, we have two nodes with values 5 and 6. So the node with lower value will come first, and the node with higher value will come later. So that's why we need to sort this, so that first it gets sorted by the row number that we have stored in our map, and then by the column number. So this is sorted, and in the end we need to return the answer in the answer, which will consist of the value of the nodes. So we'll be iterating over this vector, and we'll push the value for it, which is stored in id.second, which is a vector's ith index, and the second, the pair second element is the value of the node. We will do plus plus it, and we'll push this vector v in our answer vector. Yes, we should be good now. Let's try to compile this and check for any compilation errors. Did you mean to use line 41 for int I equals to 0, I is less than id dot second dot size. Okay, id not dot, it should be this. That's good. Let's just try to submit this. It is accepted. Thank you so much for watching.